channel. So today we are going to discuss about new topic, which is Lewis structure and also VSEPR, which is valence shell electron pair repulsion part 1. So for today's lesson, okay, the outline for this part 1 is actually after this topic, you will be able to draw a Lewis structure for di molecules. Okay, right. So first thing first, okay, you need to be able to identify which one is the valence electrons. Okay, so what is valence electrons? Okay, there are actually the outer electrons, okay, of an atom at the outermost orbitals, okay, and they usually participate in chemical bonding. So from this example, okay, so here we have group 1A, group 1, group 2, and then the transition metal and also the P group. Okay, so if we have group 1A, the electron configuration will be the NS1 and we have only one valence electron. Okay, and another example, let's say we have group 6A, the electron configuration is NS2 and P4 and the valence electron is 6. While here we have group 7A, which is, it is actually group 17, NS2 and P5 for the electron configuration, and the valence electron is 7 because 5 plus 2. Okay, so here this is example or the Lewis dot symbols, okay, where all the elements are actually showing their valence electrons. Okay, so if we have group 1, so only one valence electron for all group 1. For group 2, okay, we have 2 valence electrons. So for example, beryllium, magnesium and so on, so they show 2 valence electrons surrounding the elements, okay, and then and so on. Okay, right. So if we have, for example, group 18 or group 8A, so this one is a fully filled electron configuration. Okay, so they will show 8 valence electrons. So guys, we have discussed about the ionic bond, the covalent bond, okay, in previous topics. So in this, let's say you want to show the Lewis structure for ionic compounds or ionic bond, okay, you need to write down the valence electron, okay, surrounding the metals and also non-metal. Okay, so in this example, we have lithium fluoride. Okay, so lithium is actually from group 1. Okay, so it has one valence electron. Okay, while for the fluorine, it comes from group 17, so it has 7 valence electron. Okay, so 2, 4, 6, 7. Okay, so this is the electron configuration for lithium, while this is the electron configuration for fluorine. So because we have ionic compound, so we need to have transfer of electron. So what happened here, this lithium will donate 1 electron to the fluorine, and this electron will be accepted by the fluorine. Okay, so here we have a lithium cation, okay, and also fluoride anion here. Okay, so 1 positive and 1 negative. So for the overall, what happened here, okay, for the lithium, it will leave us with 1s2, while for the fluorine, it will have a complete or a fully filled electron configuration, which is 1s2, 2s2 and 2p6. Okay, it is from the 1s2 to s2 to p5. Okay, alright, so this is the transfer of electron. The lithium remove 1 electron and it will form lithium plus 1, okay, or lithium plus, and this electron will be accepted by the fluorine. Okay, so this fluorine accept 1 electron and it will become fluoride, okay, with fully filled electron configuration with 8 valence electron. So then they will form lithium fluoride, which is an ionic compound. Okay, so this is photo of the lithium fluoride. Okay, then other than that, we also have learned about the covalent bond. Okay, here we have polar covalent bond and also non-polar covalent bond. Okay, so in covalent bond, it is actually chemical bond in which two or more electrons are shared by two atoms. Okay, so why should two atoms share electrons? Okay, why? Because they want to achieve or they want to form gas noble electron configuration. Okay, right. So here, for example, we have fluoride. Okay, F2. Okay, so we have F2. So here, this is a sharing of electron between two fluorine atoms. Okay, so both are having 7 valence electron, and they have here equal sharing of electron here, so they will form fluorine F2. Okay, so one will be shared by this fluorine. Okay, this, let's say this is F1, this is F2. Okay, and another one, okay, this F2 share 1 electron, okay, to this F1, so they will form one single bond, okay, between fluorine here and this fluorine. Okay, alright, and then other than that, okay, so this is the single bond, and surrounding the fluorine here and here, this is what we call the lone pairs. Okay, so this is one single covalent bond that will form a sigma bond. Okay, other than that, an example here, we have a Lewis structure of water, H2O. Right, so this one also sharing of electron between hydrogen, two hydrogen molecules, two hydrogen atoms, and also one oxygen atom. Okay, so this oxygen share 2 electrons, okay, to this hydrogen and also this hydrogen, so they will form a single covalent bond or 2 sigma bond here and also here. Alright, so the correct Lewis structure of the water is like this. Okay, V shape, the V shape, or we call it as band. Okay, right, so other than single bond, we have double bond and also triple bond. So when we have the double bond, it is actually sharing of two atoms share their 2 pairs of electrons. Okay, for example, here we have carbon dioxide, CO2. CO2. So this is where we form a sigma and also pi bond. Okay, and it form a double bond here. Okay, here and also here. Right, other than that, we have triple bond. Okay, so this is where the 2 atoms share 3 pairs of electrons. Okay, for example, we have N2 or nitrogen. Okay, where they will give us a 2 pi and 1 sigma bond. Okay, share from side to side and also from side to side and also end to end. Okay, end to end sharing. This one we will discuss later. Okay, how the sigma and also pi bond form. Right, then other than that, we go to the bond length. Okay, so this is I think this is what you have know. Okay, what you have already learned. Sorry, what you have already learned before this. So here for the bond length. Okay, triple bond is much more shorter than the double bond, and then followed by the single bond. Okay, so here the CC ataupun carbon to carbon bond, we have the bond length of 154. Okay, alright, while for the double bond we have 133, and the triple bond here we have 120 picometer PM. Alright, so this is example, okay, comparison of some general properties of ionic compound and also covalent compound. Okay, so here we have sodium chloride and also tetrachloromethane. The appearance of the sodium chloride is white solid, while for the CCl4 is a colorless liquid, and the melting point of sodium chloride is 801 degrees C, while for the CCl4 is -23. Why? Because this is ionic, okay, ionic compound where we have interaction between metal and non-metal. So what happened here, the bond or the ionic bond that formed between sodium and chloride is very strong. So in order to melt, okay, this ionic compound, we need to have higher energy, okay, right? And then the molar heat, and then we have the boiling point, and so on. I think that's all for part 1. So guys, please don't forget to like, comment, and also subscribe to my channel. So I'll see you guys in part 2.